What I have here are known as stromatolites. They are fossils of very, very primitive life, very primitive life known as microbial life, prokaryotic microbial life, which includes such things used to be known as blue-green algae. Now it's known as cyanobacteria. But they're some of the very earliest forms of life that lived on the planet before 2 billion years ago. Stromatolites are some of the most abundant fossils in the very early record of life on the Earth. And they come in quite a variety of forms. There's a couple of videos on YouTube, as well as a couple that I've made, that go through the diversity of different types of stromatolites, the diversity of different forms of them, and presumably formed by different communities of microbial life living in shallow water for the most part, photosynthesizing. But an interesting aspect about this is that sometimes associated with these stromatolites are found what are essentially hydrocarbons, essentially very hard hydrocarbons, similar in some ways to, gilsonite, and similar in some ways to very hard asphalt. Hydrocarbons are essentially petroleum, and it's fairly certain that these hydrocarbons have been produced from the algae or the cyanobacteria that form the stromatolites, and represent some of the earliest organic material that exists in the rock record. Some of it extends back as far as almost 3 billion years. Stromatolites, in fact, occur back as far back as 3.5 billion years in the history of the Earth, and for literally well over 1 billion years were the major form of life that lived on the planet. Very ancient Precambrian hydrocarbons are collectively known as Anthroxolite. It's a very hard, very brittle hydrocarbon, and it is the oldest petroleum, essentially, that is found in the Earth's crust. And it's of interest because it is derived from some of the earliest life that occurred in the Earth over 2 billion years ago. And here's a few examples of them. These specimens right here, this stromatolite from the Gunflint Formation in Western Ontario. And if you look on the screen, this black material that you see right here is Anthroxolite. This is this very, very ancient Precambrian hydrocarbon that's probably produced from the algae or the cyanobacteria that you find fossilized associated with it. And here's another one from the Gunflint Formation. The black areas that you see on the screen are the areas of Anthroxolite, and it often occurs in a rather typical and characteristic signature that you see here. Actually is very typical of it. Here's another one. This is from rocks about 1.4, possibly older, 1.5 billion years, are possibly older, from southern Missouri. And again, you see that black scattering of hydrocarbon material, the mineral Anthroxolite, scattered throughout what is essentially known as a tufaceous iron formation. These stromatolites and the Anthroxolite that form from them are often found associated with what is known as iron formation, which is a peculiar rock that's characteristic of the early history of the Earth. And it appears, and today is pretty well agreed, that it's a biogenic sediment that was produced in the process of the oxidation of the Earth's atmosphere, the accumulation of oxygen that built up starting about 2.5 billion years and gradually increased to the 21% that we have today. Now, the next thing we're going to look at is going back about almost 2 more billion years. This is a slice of what is known as a carbonaceous chondritic meteorite. It fell in 1969 near the Mexican town of Allende. And carbonaceous chondrites contain a material similar to Anthroxolite. It's essentially a hydrocarbon. And being from outer space, not being from the Earth, the hydrocarbons that are found in carbonaceous chondrites are derived in some manner other than from life. For a while, there was excitement, particularly in the 1950s, that possibly carbonaceous chondrites reflected the presence of life in some other part of the solar system, or possibly beyond. But that's been pretty well written off, that what the Anthroxolite-like material found in carbonaceous chondrites is actually a synthetically produced or non-biogenic produced form of hydrocarbon that produced by a process similar to what is known as the Miller experiment, which was an experiment that was done in the 1950s, setting up a series of energy sources and subjecting a mixture of methane and ammonia and water. Essentially, over a period of time, the water would appear to be yellowish and then reddish, and finally a blackish gunk would appear, which was a hydrocarbon, or a hydrocarbon consisting of a number of other materials as well. Very similar in composition to the organic material found in these carbonaceous chondritic meteorites, the specimen like you saw on the screen from Mexico, the Allende. And the next episode in this saga of very, very ancient hydrocarbons is the mysterious reddish and yellowish, brownish material that is seen with a telescope originally on one of the satellites of Saturn, the satellite known as Titan. Titan has a reddish color to it if you look at it with a big telescope. And it was always puzzling what that reddish material is. With space probes that were sent in the 1980s, I believe, flyby to the satellite of Saturn, Titan, showed that the material is similar to the material found in carbonaceous chondrites. And in the 1990s, Carl Sagan essentially coined a term to represent this material, and what he coined is the word tholins. And they're compounds of complex organic material, but containing quite a bit of hydrocarbons, very similar to the carbon material in carbonaceous chondritic meteorites, which in turn is similar in ways to the Anthroxolite found in some of the very earliest evidence of life on the Earth.